Hello, Introduction to Psychological Science class. Today we're going to finish up our lecture notes on validity. All right, so we talked about validity in general, and we talked specifically about experimental validity, the extent to which the conclusions that we draw from our experiments are good if we've controlled for all potential confounding variables, if we can generalize to other groups of people, if we can generalize to other different situations. And we started our discussion about hypothetical constructs and operational definitions. We talked about all the different ways that we could potentially measure these hypothetical constructs that we're interested in. So how do we know if our operational definitions are doing a good job of measuring what we think that they measure? How do we know if the task and the measurements that we create in psychology do a good job of measuring the things that we think that they measure? All right. So this is the question of psychometrics. Psychometrics is a discipline within statistics and psychology all about measuring psychological phenomena. For our purposes, there are two qualities of a psychology test or a psychology measurement that we are interested in to determine if we are measuring the hypothetical construct in a good way. And these two ways of examining a psychology test are the reliability and the psychometric validity. Reliability is the consistency of our measure. If we give the person the test today and we give the person the test tomorrow, are they likely to get a similar score? Or is it the case that their score varies a lot? All right. For anything to be of use in psychology, we have to get the subject to behave consistently. Otherwise, our measure's not really doing a good job. If today our test of personality gives us that the person's an introvert, tomorrow it gives us that they're an extrovert, that test is not very reliable, and thus it's not a very good measurement. So we need to have consistency in our measurement. That's what reliability is all about. Psychometric validity is the degree to which our research measures and our research tests actually measure what they claim to. Right? It's the extent to which our measurement of self-control actually measures self-control. It's the extent to which our measure of attraction is truly measuring attraction. And there's a number of different ways to test for reliability, and there's a number of different ways that we can test and assess psychometric validity. But first, I want to talk about an important relationship between the two. Before a test can be psychometrically valid, it has to be reliable. All right, reliability is the first thing that we need to seek out. All right, it's the first thing that we need to test for. If a test is unreliable, it cannot be valid. All right, so here's a little chart that you'll always see in introductory science textbooks about the relationship between reliability and validity here. So ultimately, we're wanting to hit the bullseye here. If all the arrows are going in different directions, they're not landing in the same place, our test is unreliable. We're not getting the same score every single time. And if it's unreliable, it cannot be psychometrically valid. Again, maybe we're trying to hit the center, but maybe we're always hitting someplace to the side. Okay, we have some reliability. Every time we do our assessment, we get a similar score, but ultimately it's not at this bullseye. Okay, and then here in the middle, we have a test, metaphorically, that is both reliable and valid. Let me give you an example of this. Suppose, if you would, that we're trying to develop a measure of intelligence. Okay, and our first measure of intelligence is the Rorschach ink blot test. Rorschach ink blot test, today it might say, give you this score. Another day it might give you a completely different score. The test is completely unreliable. With this ink blot, you see faces. With the next ink blot, you see scorpions, and we can interpret that in all different ways. All right, people do not have a consistent scoring on the Rorschach ink blot test. The test is unreliable. So since it's unreliable, it's not really good for anything. Okay, and so whether or not it truly measures intelligence is moot. Okay, it's unreliable. Let's check our next potential test of intelligence. How quickly you tie your shoes. All right, and let's say we assess intelligence by how quickly someone ties their shoes. Now, there's probably some consistency to this. Some of us tie our shoes quicker than others. All right, so this test might be reliable. But is it valid? Okay, probably not. Probably the extent to which you tie your shoes, whether or not it's quick, whether or not it's very slow, probably has nothing to do with what intelligence is all about. Okay, so here we have a reliable test, but it's not valid. All right, how about the SAT? People typically get a similar score on the SAT from time 1 to time 2. So the test is reliable in this sense, and it does a great job of predicting what grades you're going to end up getting in college. Okay, so the test has a great deal of psychometric validity to it. So it's a fairly good measure of intelligence. They say aptitude, but it's really intelligence. Okay, so here we have a test that's both reliable and valid. All right, so I want you to know that the relationship between reliability and validity. Okay, how do we assess reliability? Well, it depends on what we're interested in. And when you take research methods, if you take research methods, you're going to go into all of these different ways in which you can assess reliability. Here we're going to talk about just 3. All right, test, retest reliability. We give people the test on day 1, and then we wait a certain period of time. Maybe it's a week, maybe it's 2 weeks. But then we give them the exact same measure, and we see how consistent their scores are. If you made a 50 out of 100 on day 1, did you make a 50 out of 100 on day 2? Or if it's close to 50. We actually calculate a correlation coefficient using the data from time point 1 to time point 2. Don't worry if you don't know what a correlation coefficient is. We'll talk about that later on in this course. But we do that to evaluate the degree of consistency. So test, retest, this is something that's supposed to be stable, right? Like personality. Your personality isn't supposed to change in a matter of 7 days. Your intelligence isn't likely to change over 7 days. So we might assess reliability for these things that are consistent, these traits. We might assess it with a test, retest reliability. All right. Another way that we can assess reliability is with split half reliability. Here what we do is we take whatever test it is that we have, and we take all of the items and we divide them into 2 halves. So there's the first half of the test maybe and the second half of the test. And we calculate a total of the items that you got right on the first half and the items you got right on the second half, and we correlate those totals together. All right. Maybe we do first half, second half. Maybe it's the case that we look at the odd items and the even items. Maybe this could be like a test of personality. It doesn't really matter what we're exactly examining, but we're trying to see if half the items correlates with the other half of the items. This has the benefit of we can assess reliability all in one go, as opposed to waiting a long period of time like we have to do for the test, retest reliability. So people will prefer the split half reliability if they can get away with it. All right, so that's split half reliability. For some things, we have a rater rate a certain behavior. So let's say that we're observing children. We might video record the children and then try to see if they engage in certain behaviors. Now, what might be aggression for me might look like something else to you. Okay, so we need to be consistent in how everybody scores certain behavior. We can assess the reliability of these raters by calculating an inter-rater reliability. Here we get multiple raters to rate behavior, to judge something. So let's say that we are trying to come up with a way to measure creativity, and we're like evaluating pieces of art. All right, we need to make sure that all of our raters are consistent. Okay, that whatever it is that they're examining that is supposedly good art, that at least it is consistent among all the raters. So we take rater 1 score, rater 2 score, raters 3 scores, and we see if they're consistent throughout the judging of our different subjects and different pieces of art or whatever it is that we're interested in examining. All right. Inter-rater reliability, we get multiple raters trying to see if their measurements are consistent. All right, so there's multiple ways that we can assess reliability. The important thing here to note is that, again, reliability is important because if our test is not consistent, it cannot be valid. There's no way that it can measure the construct that we're truly interested in. And again, you'll go into much greater detail in about reliability in other classes. All right. Again, I'm trying to hammer home this point. A test cannot be valid if it is not reliable. All right, different types of psychometric validity. Some people like to talk about face validity. Face validity is the extent to which our test looks like it measures the construct of interest. Okay, so maybe we have two different ways of examining memory. Okay, maybe one way is with a paired associates test. With a paired associates test, we present words in pairs, and then after a delay, we present you with those words again, and your job is to type out or say the word that corresponds to this word when you were presented with these words initially. So for instance, if we see scissors here, we saw scissors paired with oven beforehand, so we need to say oven. Here we see the word plate. What was paired with plate beforehand? It would be mouse. So imagine this as a memory test. This doesn't seem like a memory test that you might have to do in the real world. Okay, maybe this test doesn't seem like the kind of memory that you might typically engage in. We can contrast this with maybe memory for names and memory for faces. So here in this task, we have a face, and we learn that this person is Kevin. And then later on, we see this person's face, and we need to figure out what his name was. All right. This seems much more similar to what we might engage with in the real world. This seems like it's a better measure of memory because it looks like something that we engage in with the real world. But face validity is not a good way of examining psychometric validity. All right. So here I have face validity is not a type of validity. All right. It's not. The extent to which your test looks like it measures the construct sometimes is of no consequence. All right. So this test that seems like it has nothing to do with memory in the real world, this is very similar to how we learn new words. Okay. Or if we're trying to learn a foreign language, we're trying to pair the word in English with the foreign word. So this paired associates test actually does a good job of predicting how someone would learn a new language. All right. So whether or not a test looks like it's measuring the real thing, the thing that we're interested in, is not ultimately that important. So we shouldn't put too much faith and too much interest into face validity. All right. So there are three major types of psychometric validity, and they were originally talked about in a famous paper by Lee Cronbach and Paul Mill in 1955. It's one of those papers that like any psychologist that goes to graduate school needs to read, but it is a boring paper. It is not very exciting. And because Cronbach and Mill hated undergraduate students, all of these different types of validity begin with the letter C. So they're going to be confusing for you. And I just want you to keep that in your mind because you might be confused by these things, and it's important that you're able to distinguish them. All right, so they are content validity, criterion validity, and construct validity. Content validity is the extent to which our test measures all of the facets, all of the subcomponents of our measure of interest. So suppose we're trying to create a test to examine how much math you learned in high school. Okay, we could come up with a test that only asks problems about right triangles. All right, just every single problem about right triangles. Now, does that measure something to do with high school math? Yes, you did have a class in geometry, but that's not everything. It's only measuring a small part of what you did in high school math. So to create a better test, to have better content validity, we have to fully measure the entire extent of this construct. So we need to measure, we have to ask questions about geometry, about trigonometry, about algebra, and all these different things that you learned in high school, not just about right triangles. Right triangles are important, but they are only a small part of everything that you learned in high school math. All right, how about if we're interested in how agreeable someone is? This is a personality trait. So maybe we just ask questions about how modest a person is. Okay, are you a person that doesn't like to brag about yourself? Well, that's definitely one important component of somebody being agreeable, but agreeableness encompasses a lot more. All right, agreeableness encompasses modesty, but it also encompasses altruism, whether or not you like to do good things and do good deeds for other people. All right, whether or not you are very truthful, so whether or not people can trust you. So there's plenty of aspects of agreeableness that's not just modesty. And if we're trying to measure this construct, we need to measure all of the relevant subcomponents. That's what content validity is all about. How do we make sure that we have good content validity? Well, one thing that we can do is look at theory and see what theory has to say about our construct of interest. Maybe there's 3 important aspects of this construct. Another thing that we can do is look at a content expert. So if we were trying to create a high school math achievement test, we should talk to high school math instructors to see what they actually teach to help design the test. All right. My wife was helping design a test for experts at the tool rental place within Home Depot. And one of the ways that she helped create this test was by going to content experts, those individuals that work that job, and they helped come up with the skills and the kind of questions that someone that is going to succeed at that job should know. All right, so we go to content experts, we look at theory to make sure that we have good content validity for our assessment. All right, next, another C word, we have criterion validity. Criterion means something that we're trying to predict. And criterion validity is the extent to which our test predicts real-world important outcomes. All right. Our high school math achievement test should be able to predict someone's math grades in college. All right. We should see that it actually is predicting real-world performance. Maybe our measures of agreeableness should predict the number of friends that somebody has. Maybe how successful one's relationships with other people are. All right. If we're trying to have a test of anxiety, maybe that test of anxiety should be able to predict whether or not someone's likely to warrant a clinical diagnosis of some sort. So we should be able to predict real-world outcomes with our tests. Okay. Another example here: intelligence tests. They should be correlated with maybe how well you do your job, okay, maybe how high you go in your job, so what's your occupational attainment, okay. So with criterion validity, we are concerned with predicting real-world consequences, all right. Our measure of self-control should predict who is likely to end up in prison. People with poor self-control are probably more likely to end up in prison. So we should be able to see that our tests that we design in psychology predict real-world consequences. That is criterion validity. Lastly here, we have construct validity. Construct validity is the extent to which our test correlates with similar measures that are supposedly measuring the same thing, and the extent to which it does not correlate with dissimilar hypothetical constructs. So if we create a new test of intelligence, it should correlate with the older test of intelligence. It should correlate with the Stanford-Binet. It should correlate with the Wechsler scales of intelligence. Okay. If our measure of intelligence is more strongly correlated with socioeconomic status, or maybe the individual's race, than it is with other measures of intelligence, we've got a problem. Okay. Our test is not doing a good job of predicting the construct of interest. It's measuring something else. All right. So our test of math achievement should be more strongly correlated with our math grades than they are our English grades. So we should see that relationship. Okay. They probably will be correlated with our English grades because school performance is all correlated with one another, but we should see a stronger relationship with your performance in a math class. Okay. So those are the 3 major types of psychometric validity. And anytime we come up with a new test in psychology, we're trying to evaluate all those types of validity to make sure that our operational definition does a good job of measuring the hypothetical construct of interest. Now, 2 things that might impact our validity that I want to mention are floor effects and ceiling effects. A floor effect is where the test is too hard and everybody is likely to score really, really low. Okay. If everybody scores really low, I can't tell any differences in performance between people. I can't tell who's good at this task or who's bad at this task because everybody has scored really poorly. Same thing if we're looking at a test of personality. I can't tell who's agreeable and who's not agreeable because everybody circled the same answer choice. Let me give you an example of a floor effect real quick. All right. So let's say I have a test of math ability that I'm trying to see which of all of you guys are good at math. And I ask the following problem, right? If we're doing a little bit of calculus. Everybody's likely to get this problem wrong, all right? I'm looking at this thing. I can't do it right now as well, okay? It's a difficult problem. So I can't tell who's good and bad at math because everybody gets this problem wrong. Everybody is at floor. So I need to make sure that people are going to vary in how they answer the question when I am developing a test. Now, a similar problem to a floor effect is a ceiling effect. And a ceiling effect, our test scores are too high, maybe the test is too easy for everybody, and everybody scores really well. Again, maybe I'm creating a test of math ability and I'm trying to see how everybody in the class solves math problems. And maybe my question is, what's 1 + 1? Everybody should get this answer right. So since everybody gets it right, I have no variability and I can't tell who's good at math and who's bad at math because everybody is performing perfectly. This is something not just with cognitive ability measures. We can find this with measures of personality as well. So how about if I ask the question, have you ever at any point in time in your life ever told a lie? Now, everybody at some point in time has told a lie. So everybody for this question should say, yeah, at some point in time, I've told a lie. Well, now everybody is at floor. If I'm trying to predict how trustworthy a person is, everybody's got the same score, and I can't really do a good job of that. Okay. Maybe if I'm trying to measure agreeableness, maybe in a different way, and I say, how many people would kick this cute kitten? Everybody should say, no, I would never want to kick that cute kitten. All right, since everybody says no, they get a very, very high agreeable score, but it truly doesn't tell me how nice that person is, okay? Because no one would kick that kitten. All right, so we need to be mindful of floor and ceiling effects when we are creating our test and to try to make it be the case that there's some variability in whatever scores there are when we're trying to measure a hypothetical construct. All right, the last thing, and this is an important topic, but it's also a difficult topic. This is the Duhem-Quine thesis, the Duhem-Quine thesis. And this is a idea by philosophers about what happens when scientists test their hypotheses, when they conduct an experiment. Well, if our experiment doesn't work out, if our experiment fails and we don't find what we intended to finding, it's not just the case that maybe our hypothesis is wrong. There are multiple reasons why our experiment could fail. Okay. When we are designing a study, there are 3 kinds of statements that we end up making. There are theoretical statements, there are mapping statements, and there are auxiliary statements. Theoretical statements are what we're ultimately interested in a study. Okay, how the hypothetical constructs are related to one another. So maybe going back to an earlier example, maybe frustration causes aggression. My theoretical statement I'm trying to test is, does frustration always lead to aggression? Okay, that's my theoretical statement. Mapping statement, these have to do with how our hypothetical constructs are operationally defined. Okay, maybe I'm measuring frustration by changing the way that traffic flows. Okay, is that a good measure of frustration or a good way to manipulate frustration? That's what the mapping statement is all about. Maybe I'm measuring aggression by how many people shoot the middle finger up in the air. Is that a good measure of aggression? Okay, that's what the mapping statements are saying. All right, the last statements that we end up making with our study are auxiliary statements. All right, this is the specific way that we collect our data. Do we have somebody with binoculars that's trying to see who is shooting the middle finger? Are we doing this study in the morning or in the nighttime or at 5 o'clock? All right. How much are we limiting traffic by? All of these things are the auxiliary statements. So let's say that we conduct our study, and at a certain period of time, we restrict traffic flow out of UNG, and we count how many people wave middle fingers in the air. And let's say that we do not find that when we change how much traffic there is by artificially creating traffic, that it doesn't lead to an increase in middle fingers. Now, why is that the case? Is it the case that frustration does not lead to aggression? Is that the case? That could be the case, but it could also additionally be the case that maybe our operational definitions are bad. Maybe how many middle fingers up in the air is not a good measure of aggression. That could also be the case. Maybe it's the case that how we measured things was not good. Maybe the binoculars, we couldn't really see everybody with their middle finger up in the air. Maybe it's the case that that is a good measure of aggression, but our research assistants could not see it. All right. So our study, whenever we conduct an experiment in psychology, the results of them are a combination of these three different types of statements. And if our study works out or if it doesn't work out, we don't know which of these statements is off, which one of these statements is problematic. Is it truly the case that frustration does not lead to aggression? Maybe that's the case, but maybe our operational definitions are poor. Okay, we don't know which category of statements turned out to be false when we are conducting our experiment. All right, that's problematic. Okay, ultimately we're interested in these theoretical statements, but we always have to be mindful that maybe our study doesn't work out. Maybe the results of our study have to do with these mapping statements or auxiliary statements instead of the theoretical statements. Okay, so again, the Duhem-Quine hypothesis is that when we are running an experiment, when we're running a research study, we're not just testing the theoretical statements. We're testing our theoretical, our mapping, and our auxiliary statements. So the conclusions of our study, we need to be mindful that they might not just tell us about the theoretical statements. I hope that makes sense. All right, so that's the end of our validity discussion. I hope you guys have a great day, and I will talk with you later. Bye-bye.